today we want to discuss the relevance of the x and the y components in projectile motion. Projectile motion. Now, always note that when a body is propelled, let's say from A, it moves up to the maximum height, then comes down. It has two components, the x and the y component. The x component is along this side, just as you know for your mathematics graph, and the y component is always directed just at some point tangent to the line. That is, if it's at this point, the y component is always like this, like this, like this. Now, the x component of it is important to know that the x component of the velocity of an object is always constant. That is, ux is equals to vx. Initial x velocity is equals to final x velocity. Always try to understand that the initial x velocity is equals to the final x velocity. Now, which means that at this point, one of the fallacies that we will try to say no to is that the velocity at the top or at the maximum height is 0. That is no. It is better to say that the velocity at the y component is 0, not velocity at, because the s component of the velocity is always constant. Look at that. You have the s component of this velocity here is constant. It is not 0 here. It is only the y component that is equals to 0. Now, what do you observe there? The velocity is changing. That is, from this point, we go down from this point, then come up, then come down. As we are moving, as this ball moves, the y velocity in the y component changes, but the velocity in the s component remains constant. Now, look at this scenario where the velocity, where the y velocity changes. Now we'll try to make some distinctions between the x and the y velocity and x and y directions generally. Now let's take A as x and A as y. Now, one of the differences is 1. In the x direction, acceleration in the x direction is equals to 0, while acceleration in the y direction can be plus g if it is moving downwards, or minus g if it is moving upwards. If it is moving upwards, is minus g, while it's moving downward, it is plus g, while acceleration in the x direction is 0. Now let's use this information to derive some equations. Remember your Newton's first law, Newton's laws rather, s equals to ut plus half ac squared. Now, in the case of the x direction, let's call the distance x, that is horizontal distance, and this is vertical distance. Now, here we can write as x equals to uxt x equals to uxt plus half axt squared. Remember that as is equals to 0, therefore s is equals to uxt. Note that this equation is relevant only for x direction movements. And how do you differentiate x direction movement from y direction movement? Simple. Look at your question. Most questions that want you to assume the x direction will tell you a ball is projected horizontally. Anywhere you see the word horizontally, then the parameters given are only for the horizontal directions. Now let's take some few examples of what we have been talking about. Now, a ball is projected horizontally from the top of a building 4 meters high. It's projected horizontally. This how is gonna be. If it is projected vertically upwards, it's gonna look like this. But if it is projected horizontally, it's going to come down like this. Horizontally, it's going to come down like this. Now, it is projected horizontally with a velocity of 15 meters per second for 0.2 seconds. The question is, calculate the distance moved. Of course, everyone can do this, and that is where you have to be careful, because x is equals to uxt and u here is equals to ux because the question tells us it is an horizontal movement. So the velocity will be an horizontal velocity. So ux will be equals to 15 meters per second, and the time will be equals to 0.2 seconds. Therefore, s is equals to uxt is equals to ux is 15, t is 0.2. So when you multiply it together, we have 3 seconds. 3 meters rather. We have 3 meters. Therefore, the horizontal distance is equals to 3 meters. Not s is equals to uxt plus half axt square, because ax here is equals to 0. Ax is equals to 0. Let's look at this question. If it takes 0.5 seconds for the ball to fall freely from R, I see R to P, the diagram PQ, if the horizontal velocity is of 14 meters per second is dash. Now the question we are asked to solve here is to get the horizontal velocity. Now apparently here we know what the time is. The time here is 0.5 seconds and the velocity is 14 meters per second. Of course, you guessed it right. That should be the horizontal velocity because we are told the ball flows horizontally. Therefore, x is equals to vxt or uxt plus half axt square, of which ax is equals to 0. Therefore, we now have s is equals to us is 14, the time is 0.5. Multiply together plus half times 0 times t square. Hence, we have 14 times 0.5. 14 times 0.5 will give you 7 meters. Therefore, the horizontal distance is equals to 7 meters. Some people call horizontal distance range. We also agree with that. If you are asked to calculate the horizontal distance traveled, it's the same as saying calculate the range. They are the same. Now we continue from this place next class. Thank you.